Michael Norman, also known as Stormin Norman, here with you again, Automation and Controls Engineer with Scott Equipment Company in Charlotte, North Carolina. Today I have Darren Jacobs with me. How you doing, Darren?
Hey, I'm doing good, Stormin Norman.
Glad for you to be here today.
I'm glad to be here.
So we have a Precise Automation collaborative robot in front of us. Could you explain what makes a robot collaborative?
Absolutely. The typical industrial robots are known to have potential for injury, so they have safety guarding.
Correct.
And light curtains,
lots
different
of light
things
curtains,
like that.
Lots of safety devices.
For prevention of
Right.
injury. So what's different about the collaborative robots is they're actually intended to work side by side with somebody.
Okay, so if I'm standing here and I'm in a work cell and I'm working right next to this robot and I get into a pinch point, he's going to stop, correct?
Absolutely, and that's what a collaborative robot would do. It's force limited. It is actually utilizing software and also the sensing of the collision, and then it's stopping, and it's actually going into with the right software. We have what we call recovery.
So
routines,
how would we actually go into recovery mode?
Well, basically we have software in place to do that. The robot is force limited, so it's actually going to stop based on force. And then what is it going to do after that? That has to be programmed into the robot. So we have what's called automated recovery routines. And you can see in our environment here, this is the program we're talking about here. The operator gets in the way, interrupts the program, that doesn't drop the part. This is all programmed into our web-based software under the recovery routine. You can customize this any way that you'd like. Very simple, easy to do. And in this case, what happens if there's a collision? So you just insert as many commands as you want. In this case, you can select from turning on the motor, moving to a remote point, return to the program, lock or remove lock on axis. It's very customizable. And so he simply plugs that in and goes right back to work. You can see the demonstration again. It holds on to the part and doesn't have to start from the beginning again. It goes right back to what it was going to do. It places the part and picks up another part. There are some other additional features that we have, like inaccurate part placement. Right here you can see it's looking for the bearing. It's not there. So what does it do? It tries to repeat to pick it up, and then once it does, it would error out after a while. So that's all, like I said, customizable. So very friendly to work with, work side by side with. You could imagine a benchtop application working next to somebody, easy to program, easy to work with, goes right back to work. So not like robots of the old days, I would say.
So a lot of flexibility built into the recovery actions that you can take. You have a lot of decisions you can make once you actually have to recover.
Right, because all parts are different and different requirements for application.
Exactly. Yeah. Much easier, much quicker.
Right.
All right. Thanks for coming by.
Hey, I appreciate it.
Absolutely.
All right.
Again, Michael Norman, also known as Stormin Norman, with Scott Equipment Company in Charlotte, North Carolina. Feel free to give me a call or us a call about any of your collaborative robot needs.